Okay, so like I said just a second ago, today we're simply going to classify polynomials. And there's two ways of doing it. It's going to be a very simple lesson, and your assignment tonight will be very simple as well. Okay? If you didn't finish your homework from last night, then you can spend some time on the ones we didn't do together in the class. But we are going to discuss the two different ways to classify polynomials. All right? Two different ways. One is going to be based on the size of the polynomial, and then the other one's going to be based on the degree. So in order to understand that, you need to know what that means. So here's what we got. The highest exponent of that polynomial, that is what we call the degree. All right? The highest exponent. So if I look at all of these polynomials and I see the highest exponent, that is how we're going to classify it by the degree. Now we're going to do that mainly when we're talking about polynomials like number 10 that only have one variable. When they have two variables, it gets a little trickier, but we'll discuss that in just a second. So first, when we discuss this thing called standard form of a polynomial, it's kind of funky. Here's what the book describes as the standard form, and we don't have a book, but when we talk about the standard form of a polynomial, it looks like this. A sub n x with the postscript n raised to the n power plus a sub n minus 1 x raised to the n minus 1 plus a sub n minus 2 x raised to the n minus 2 power plus dot 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 c. It's crazy. You don't have to remember that. Dot 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 means that it's going to keep on going until it gets to c. And what do we refer to as c? Our constant. So let me explain, because that's just the equation that represents what's happening. And here's what's happening. Let's say n was 5. What would then be in this spot right here if n was 5? 5, right? So this would be x to the 5th. Now, if n is 5, what would be the next term if I plug 5 in here? 5 minus 1 is 4. What would be the next term if I plug 5 in here? 3. All this equation is saying to you is to be in standard form, your exponents have to do what? They have to go down. Do y'all hear me? That's all this is saying. And it has to go down until you eventually reach your what? Your constant. Why would your constant be last? Your constant has no whats? It has no variables. So your constant has to be last. Now, in a case where you have multiple variables, you're going to go based on alphabet and then your biggest exponent for that alphabet. Do you understand? All right, so look, an example of what this really looks like would be something like this. 2x to the 5th plus 3x to the 4th minus 9x squared plus 7x minus 12. That's what standard form looks like. What are the variables definitely doing? What are the exponents definitely doing? What are they doing, y'all? They're going down. Now, if I asked you, hey, what's the degree of this example? What does it say above? The highest exponent of a polynomial is called the degree. What's the degree of that polynomial I just wrote? 5. 5. Why? Because that's my biggest what? That's my biggest exponent. So this would have a degree of 5. All right, so number 10 asked me, hey, write this in standard form. So I look all the way through it, and I try to find my biggest exponent. Y'all see it? What is it? Yep, that's it right there. -5 or -k to the 5th. That's got to be my first term. Now we try to work our way down. Do y'all see a 4? Y'all want to say yes or no? Y'all see a 4? No? Do you see a 3? Then that has to be next. -3k cubed. Do y'all see a 2? Yep, plus 1/4 k squared. Do y'all see a k just alone? So it's got to be plus 8k. And we work our way all the way down to where we have no more k's, which do we have a constant? -1. Now, this polynomial is in standard form. This is easy, right? This is easy. Now, number 11 might be a little bit trickier because it has how many variables? So we think alphabetically. Which one comes first, A or B? Then we're going to start with our biggest A exponent. Where's my biggest A exponent? 4a cubed, right? Then that has to be what's out front. So we're only going to think about the terms in regards to their A coefficient. So do we have one that has A squared? Which one? Is that a positive 18 or a negative? So we're going to use plus 18 A squared B squared. Do we have just an A? Yes. So we're going to do that next, plus 7AB. All the way down to, well, there's no constant, but we do have just a B squared. So we do minus B squared. Now, that is in standard form because we started alphabetically with our biggest exponent. It didn't have a constant, but if we had a constant, it has to go where? At the very end, past everything else. You understand? All right, last one then. We have X and Y, don't we? So alphabetically, which one's first? Which one has the biggest X exponent? 9x cubed y, correct? So we're going to start with 9x cubed y. And we're going to watch those x's diminish. Do we have an x squared anywhere? Yep, we got minus x squared. Do we have an x somewhere? Yep, we've got positive 5xy squared. We have no more x's, but are we ready for our constant yet? No, there's one more term, which is our biggest y term, minus y to the 4th. And now we can finish it off with our constant. Our constant is always last. So there you have it. We've written it in standard form. On your assignment tonight, there's going to be a part where you have to write it in standard form. Can y'all do that? You can do that. Now, to our classifications. We are classifying it by two things. One, the degree. The degree. What did we say the degree is? Your biggest exponent. Whatever your biggest exponent is will determine one of our classifications. The second thing that we're going to talk about and classify polynomials by are how many terms they have. How many different parts are separated by pluses and minuses? Those are the two ways that we're going to define or classify polynomials. So first, let's start with degree. If we have 0 degree, now 0 degree would mean what? No exponent, meaning no variable at all. If there's no exponent, no variable at all, it's a constant. A constant. Y'all see one of these over here? Y'all see a constant over here to your right? Which one's a constant? 15. 15 would be a constant. Okay? All of these are in standard form for me, by the way. Number 15 is the only one that has no term that has a variable. So it's a constant. What if my biggest exponent was a 1? If my biggest exponent was a 1, doesn't that mean my biggest variable is x? X to the first? Do you know what you called those in the past? Think about Algebra 1. Didn't you deal with a lot of just like 3x minus 12? Or 1/3 x plus 7? What were those? They were lines. So if your degree, if your biggest exponent is a 1, it's what we would call linear. Linear. Do y'all see one that's linear? Which one? 13 is linear. Why? Because my biggest exponent is x to the first, 1. So by degree, it's linear. Y'all understand that? Next, if your biggest exponent is 2, that's x squared. X squared, your biggest exponent. What have we called those this year? We're factoring them. We're graphing them. We're talking about them. We've said this word a ton. If your biggest exponent is x squared, 2, what have we called them? That's based on how many terms. I'm saying if your biggest exponent is squared, what have we called those? Quadratic. Have y'all heard us say quadratic? Quadratic? Graphing quadratics. Quadratic formula. Quadratic formula only works when we're dealing with x squared as my biggest exponent.
17.
Yep, 17 is quadratic. 17 is quadratic because my biggest exponent is x squared. Next, if my biggest exponent's a 3, that's x cubed. X cubed. What do you think it's called? It's called cubic. Cubic. Do I have any up here to the right that are where your biggest exponent is a cube? Number 16 is cubic. You with me over there, Kara? Oops. Video. I'm just joking.
Didn't they hear that?
No, they didn't hear it.
Next.
Next period. If your biggest exponent is a 4, x to the 4th, if that's your biggest one, this one's called a quartic. 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 Do we have any that are quartic? Yeah, 18. That's a quartic polynomial. And then the last one is x to the 5th. Does anybody know what that's called? Quintic. Quintic. So yes, see how 14's biggest exponent's a 5? That one is going to be classified as a quintic polynomial. And that's it, y'all. That's all there is. Past 5, we won't classify them by any terminology. In our class, we're not going to get above this, okay? As far as us talking about the classifications. So if your biggest exponent is 0, it's a constant. If your biggest exponent is x to the 1st, linear. If your biggest one is x to the 2nd, quadratic. X cubed, cubic. X to the 4th, quartic. X to the 5th, quintic. Now we classify by the number of terms. And someone has already referred to this. A minute ago, I heard the word binomial. Binomial. Somebody said that, remember? Binomial means it has how many terms? 2. So 2 is a binomial. Y'all remember what one term is? monomial. We already talked about it. Monomial. We talked about it yesterday, actually. And we've also talked about three terms. Remember, we were graphing these, or we were factoring these. We called them trinomials. And if it has four or more terms, we don't have any special terminology after this except for one, and those are polynomials. What does poly mean, y'all? It means many. Many. So it has many terms. So look at these over here to the right. Look at 13. Yes, it's linear, but how many terms does it have? 1, 2. So it's linear, what? Binomial. It's a linear binomial. One is based on the degree, the other one is based on the number of terms. You all understand that? Next, how many terms do we have here on 14? 3. So it's quintic, what? It's a quintic trinomial. How about 24? It's just one term, isn't it? So it's a constant because there's no x, but there's one term, so it's a... So this one's a constant monomial. All constants would be monomials, because if it doesn't have any other variable, it has to only have a constant, so it's a monomial. Look at the next one. How many terms do we have here? 1, 2, 3, 4. So it's a cubic what? Polynomial. 4 or more, we're just going to call it polynomial. Many terms. Look at number 17. How many terms do we have here, y'all? So it's a quadratic trinomial. Are y'all following? This is so easy if you're paying attention. If you're paying attention. Last one, we already said it's quartic because my biggest degree is 4. But how many terms is that? 1. So it's a quintic or quartic monomial. So to finish off this lesson, they want me to give them an example of a cubic binomial. So let's start with the part that's first, cubic. Cubic means what, y'all? Your biggest exponent has to be 3. So somebody give me a term that has x cubed as your biggest exponent. 4x cubed. Now, the next term says binomial. Binomial means it has to have how many terms? 2 terms. Well, we already have one term. But let's do a second term. What has to be the case with the second term? It has to be any term that is smaller than x cubed. Think about it. If I did an x to the 5th term, all of a sudden, didn't I just change the degree? Don't want to change the degree. So could I use x squared? Could I use x? Could I use a constant? I could use any of those 3. I just need one more term. So somebody come up with another term. Plus. We want to use plus. And what did I hear? Just plus 7. There you go. That's a cubic binomial. How about a linear monomial? Well, linear tells me what, y'all? All I can have is what variable? X to the first. So somebody come up with a good x to the first. Negative 13x. How about that? That sounds funner. Negative 13x. What's the next word tell me? Monomial. Do I need another term? Nope, there's a linear monomial right there. So, we classified polynomials. We wrote polynomials in standard form, and we classify polynomials by their degree, their biggest exponent, and by their number of terms. So if you go to that third page where you had a homework assignment last night, I want you to do numbers 9 through 12. So easy. 9 through 12. I'm giving you a big, tough assignment tonight. 4 problems. Write them in standard form, and then classify the polynomial by both the degree and the number of terms. So how many words should you write? 2. Okay, so put it in standard form, and then write the 2 words that describe it. All right? Huh? Today is the 18th of September.